So you'll have this. Good afternoon, everybody. We're going to start the plenary. If you're in the poster hall or still wandering around, now is an excellent time to find the best seats in the house. Hi, Walter. Thank you for laughing at my joke. So, hello, everybody. My name is Diego Melgar from the University of Oregon. And welcome all here in person and that are tuning in online to this plenary panel on the future of tsunami hazards and readiness research. First of all, let me welcome you all back, or if you're here for the first time, to Puerto Rico. I hope you've enjoyed the meeting so far. Please remember to thank Liz Vanacore and Shirley Perez Campos, if you see them around the meeting, for putting the technical program together. Do the same for the wonderful SSA staff that work tirelessly to make a seamless meeting happen. All of us being here in this room in Puerto Rico is really something that has been a long time coming. Remember that we were supposed to be here in 2018, right? And then a series of hurricanes had other plans for us. So it's taken a lot of effort and a lot of work to get us all together here. So thank you all for coming, and thanks SSA, and thanks everyone for putting this together. Nan Broadbent asked me to make a couple of announcements. We're looking for ideas for the next topical meeting. The next two meetings are already scheduled. One will be on physics-based ground motion modeling, and the second one will be on photonics and seismology. So we want your ideas. If you have a burning desire to help to run a technical meeting, please come to the booth on the third floor and write down your ideas and suggestions. As a bribe, you will get a Yeti mug if you come and do this, but you also have to talk to Hiroshi Kawase and Anne-Marie Balte about what running a topical meeting is all about. So with that, I want to introduce our panelists today. We will discuss recent regional and national advances in tsunami hazards research and risk mitigation, as well as planning. Hopefully today we'll cover a broad swath of issues, ranging from the science of tsunamis all the way through to maybe thorny issues of policy. The format for today will be that I will give each of the panelists a short spell of time to make remarks, brief remarks, and then we will follow that by discussion. And there will be microphones there in the aisles, so please feel free to come up and ask your questions. Our panelists are Christa von Hillebrandt-Andrade. She is the Deputy Director of the International Tsunami Information Center's Caribbean office, and she's a past director of the Puerto Rico Seismic Network. Christa, as all of you probably know, has a wealth of experience in developing real-time data acquisition systems, rapid response capabilities, and pioneering public outreach and education efforts that have had a profound impact on earthquake and tsunami preparedness. We also have with us Alberto Lopez Venegas. He is a professor in the Department of Geology at the University of Puerto Rico here in Mayagüez, and has also worked with the Puerto Rico Seismic Network extensively in seismology and geodesy, and has significant experience on both earthquake and tsunami hazards in Puerto Rico and throughout the Caribbean region. And last but not least, we have Dr. Rocky Lopes. He is a professional emergency manager with an applied social science academic background. He worked as a contractor for NOAA's National Weather Service Tsunami program from 2009 all the way through to his retirement in 2019. Now, Dr. Lopes serves as the co-chair of the NOAA Science Advisory Board's Tsunami Science and Technology Advisory Panel, the TSTAP, and he told me earlier today that this is his 45th time in Puerto Rico. So a lot of expertise amongst our panelists. So with that, I'll turn it over to you, Christa, please, for your remarks.
Well, good afternoon, and so nice to have you in Puerto Rico and in a tsunami-ready Puerto Rico. So Puerto Rico is one of the first jurisdictions in the United States that had, by making its 46 coastal municipalities, 2 of which are a little bit inland, but it could be affected by tsunamis. They met the National Weather Service guidelines for being recognized as tsunami-ready through a 10-year process, which culminated in 2015, and now every year they renew each other. So that's why as you walk around, you see signs, you see maps. That's all part of the tsunami-ready process here in Puerto Rico. And so, you know, these people that are the pictures that you're seeing are people that live, work, take a vacation along beaches, and are along coastal zones, and or work in the coastal waters. And their expectation is pretty simple. If there is a tsunami, they're going to be alerted, and they're being told where to go. Now, of course, they have this expectation only if they realize there is a tsunami threat, which is not always the case. Before COVID, I used to go on a lot of cruises. Always had fun talking with cruise ship captains, and I'd say, hey, you know, about tsunamis, and they were like, well, yeah, I know that happens in the Pacific. I said, no, here in the Caribbean. No, tsunamis in the Caribbean? I said, yeah. And I'd give them a talk, you know, and we talk about it and chat it up, and they're like, well, good to know. I really didn't realize that. And so, you know, that's, you know, that there's still a lot of people out there that are just not aware. So that's the first thing, is creating that risk awareness. So when it comes to tsunamis, the winner of tsunamis and tsunami occurrence is definitely Pacific. You know, over 75% of tsunamis occur in the Pacific region, and only 10% of them are in the Caribbean. And so in the Caribbean, we sort of have 2 issues. So one, there's, at the international, intergovernmental level, there was like, you know, for many years, they didn't consider it necessary to have a tsunami warning system in the Caribbean. The only one that existed was the one in the Pacific. And then for the local authorities and national authorities, were so overshadowed in tsunamis by other types of events. For example, hurricanes. You know, for the same time period that we've had, you know, like 70, I think the latest number was 79 definite and probable tsunamis. Probably had over 6,000 hurricanes come through at some place in the Caribbean. Not causing damage, but, you know, just as a tsunami, it made its appearance and went. So one of our biggest challenges in the Caribbean and in Puerto Rico is, you know, for many years, was the infrequency of tsunamis. The infrequencies of tsunamis is actually a threat. It's actually a hazard, because it can make us, and has made us, extremely complacent. In 1996, when we first started to talk about, you know, realizing that, you know, we better get ready for a tsunami in Puerto Rico, 2 of our 4 big earthquakes had tsunamis, and 2 of them causing deaths either in the Virgin Islands or here in Puerto Rico. And so when we started and we had our first meetings, emergency manager said, you know, tsunamis are the peligro olvidado, the forgotten danger. So that was the case, you know, and we tried, and, you know, and we had a couple of efforts at the turn of the century where we got some funding and we started to create tsunami inundation maps. But people were like, what are they doing? What are they talking about, right? Because it just was something just so, people were just very, very unaware. So it took, you know, the loss of life of over 250,000 people in the Indian Ocean. 225,000 people in the Indian Ocean in 2004. They were caught unaware. The probability of the percentage of tsunamis in the Indian Ocean is identical to the percentage of tsunamis in the Caribbean. We're both at 10%. What happened in the Indian Ocean could have happened to us here. We could have been caught totally unaware of what was going on. Unfortunately, for all those lives that were lost in the Indian Ocean, I mean, they opened up a whole window and a realization and awareness that tsunamis was not just a problem of the Pacific. The problem is an issue, it's a threat for other regions, and then the intergovernmental coordination groups were made for the Northeast Atlantic and the Mediterranean. Another one was created for the Indian Ocean, and then one for the Caribbean. All of us organized under the UNESCO Intergovernmental Oceanographic Commission. So it is a member state-driven effort. So through this effort, so the alignments, you know, the different areas of focus were developed. And so through the UNESCO IOC Assembly, these systems were established, the guidance and the marching orders were given to agencies and suggestions made, recommendations to member states. Tsunami warning centers came on board to provide tsunami services. National authorities developed their tsunami warning systems, and then the public, there's the public that's at risk, then receives this information or this training or these updates, and or just, you know, just because, so they get official alerts, or just sometimes just based on what is happening. So we have that part is now in place. And so as part of the, you know, tsunamis are extremely infrequent. And so you tell people, well, you know, you have to get ready for a tsunami. I mean, when we told countries in the Caribbean, you know, early on in 2004, how do you do that? How do you get ready for a tsunami? How does that work? And so in the United States, we'd already had the Tsunami Ready program had already been established. And so over the years, they had seen how, through a set of indicators, countries could then get ready for tsunamis as best as possible. And so through different areas working on assessment, preparedness, and response. So in 2022, the UNESCO, just last year, the Tsunami UNESCO IOC, after 10 years of working on this project, we established the Tsunami Ready program. And there's a goal that by 2030, as part of the UN the Decade of Ocean Science for Sustainable Development, 100% of communities will be at risk of tsunamis, will be prepared for and resilient to tsunamis by 2030 through programs like Tsunami Ready. And as part of this exercise, then as part of that, this preparedness, we have the issue of validating responses and plans and advancing awareness. And in the Caribbean, we have two efforts. You know, tsunamis can very easily just drop off the priority list. I mean, we have a lot of stuff going on. And these events are very infrequent that lead to people like saying, okay, you know, I better worry about the hurricanes, and we have droughts, and then we have, of course, we just went through COVID, and, you know, and we have hurricanes, you know, we have volcanoes. So what we do is we had a two-pronged preparedness. So we do two things to keep people ready and, you know, keep people on guard. One is tsunami exercise. So through Caribe Wave exercise, we hold that every year. Territories get to practice different scenarios and get ready. And last year, this year, over 421,000 people were registered participants in 2023 in the exercise. And then on World Tsunami Awareness Day on November 5th is another opportunity that we have to prepare for this type of event. So we work on that. So, you know, from Puerto Rico and US Virgin Islands to India, tsunami-ready communities around the globe becoming tsunami ready. So the idea is that by 2030, all communities, 100% of communities at risk, doesn't depend whether you're rich or poor, you're a big country, you're a small community, you're an able person, you have a person with disabilities, anything, everybody should have a level of readiness. And so that's what we're hoping, that's what we're working for, and that's what we hope to achieve by 2030. A lot of efforts have been made through Tsunami Ready, and it's great to see people around the world. And, you know, back to the original thought, you know, it's you know, when we go back to the original, you know, if, you know, these are infrequent events, but when they hit, they can hit hard and they can kill tons and tons of people and really affect life. And the only way, we just have to get ready, because if we don't get ready, people are gonna die, and we don't want that to happen. So that's the road that we have, getting ready, getting tsunami ready. Thank you.
Thank you, Christa. Alberto?
Okay. Good evening, everyone. Let's just wait for my, yes, thank you. Okay, so it was nice for Christa to make a presentation of, or introducing the Caribbean EWS ICG from UNESCO and the Intergovernmental Oceanographic Commission, because what I'm going to be presenting to you now is its work that has been the product of being part of that particular group. And I'm showing here a background of a simulation of one of these tsunami sources that one of these groups that is part of the ICG Caribbean EWS has done in the past. Before I start making my remarks, I wanted to also say that I really appreciate the members of these different groups. In particular, I have been a member of Working Group 2, which works with tsunami hazard assessment. And for 8 years, I've been part of this group, and I really appreciate all this pro bono work that many of these colleagues make in order for the advancement of tsunami preparedness in the Caribbean. So I'm the one in charge here. We're talking a little bit about science, and basically it's just how we come with these tsunami sources. Everything that is on the backstage of what Christa presented. She talked about Caribbean wave exercise. So how is it that we come up with these different tsunami scenarios and sources? So in order for us to talk about tsunami sources for the Caribbean, we need to know about the tectonics of the Caribbean plate and its geology. And for us, when we look at this particular figure, where we can see how the North America plate is on the north part of the boundary with the Caribbean plate, the South America plate, and as the Caribbean plate was formed in the Pacific domain and moved all the way to the east, where we can see it now, it has brought a bunch of things, blocks and volcanic arcs that have formed on its way to its current position. So it's a compilation of very complexly deformed boundaries. Left lateral motion predominantly on the northern part of the Caribbean. Some right lateral motion, but more complex on the southern part. The east and west are basically more typical subduction zone types, in which we have volcanoes on the Lesser Antilles Trench. We have the Lesser Antilles Volcanic Arc, and on the west we have the Middle America Trench. So within all these boundaries of the Caribbean plate, we have looked carefully using very simple ways to determine tsunami sources. But all of these has been possible as part of a group. So Christa, as she was saying, the Caribbean EWS is the perfect group for making this type of studies possible. What I'm showing here on the left is a screenshot of the Working Group 2 website of the Caribbean EWS. And if you're interested, you can just visit there and take a look of what all the different products that this working group has produced in the past years. What you can see here on the right is some photos of groups that members of this working group 2 that have become. They have met in different locations in order to discuss these different tsunami sources. For example, here in the center, on the right, is a photo of the group that composed one of the experts meeting that I'm going to be talking about a little bit, probably on the next slide. And I put this figure, I mean the photo on the right at the bottom, because I really like this photo because it shows Victor Huérfano with a Mac computer. I know he loves Macs, so. But this is one of the earlier occasions when I became part of this member group. We met in Mayagüez, and you can see here this is the old guard from the working group 2. You can see Narcís Sahibo on the left, and Aurelio Mercado, now retired from the university work, and Victor is still there. So when I mention expert meetings, it's the idea of getting together people that can produce some list of different sources. So in the meeting, I saw a couple of those persons that have participated in these meetings, and they can attest for the lively discussions that they take place there. But this is an example. For example, Haiti in 2013, there was a meeting to discuss the sources of the 1842 on the northern part of Hispaniola. The Dominican Republic meeting in 2016 to analyze sources for impact to the southern coast of the Dominican Republic. There was a meeting also in Costa Rica in 2016 for the purpose of defining credible sources impacting the Pacific and Caribbean coast of Central America. And the last one that took place in Martinique in 2019, it was with the idea of defining some sources that could affect the Lesser Antilles and the Eastern Caribbean. And all of these documents are available on the website. So you may think this is a very complicated thing, but as you can see, this is very, very simple things to do. We just have a fault with the length and the width. We compute, everyone in this room knows this equation, how to compute the seismic moment for those particular sources, so it's nothing that it's very complicated. And the end result of these expert meetings and listing tsunami sources can be seen on this web page. It's part of the NCEI, the NOAA's National Center for Environmental Information. It's called CATSAM. And CATSAM stands for Caribbean and Adjacent Regions Tsunami Sources and Models. And I really want to thank here Nick Arcos from Marine Geology and Geophysics of NOAA's NCEI, who has, for the past 3 years, he has been very instrumental in making these sources available to everyone, so we can see them. And you can see here the different boxes. They represent the different tsunami sources that this group, the Working Group 2, has devised over the years. Also, if you go into this link that shows there at the bottom, you can see this interactive tool. You can click on these different boxes and give you the information about the parameters, where which one of those expert meetings is where these particular sources were devised. And also, one of the latest things that has Nick updated to this map is the maximum wave amplitudes for each one of those tsunami sources. And that has been thanks to Jorge Macias from the University of Malaga in Spain, that has run most of the simulations and has given them to Nick so that he can put them in this map. Oops, go down. Okay. So one of the things that Christa mentioned is this Caribbean wave exercise. So when you look at these different sources here, it is a matter of taking one of these sources and putting them in line for a next Caribbean wave exercise. And you can see here, although the first one here there it says 2013. The first one of these exercises was in 2011. But this shows as a compilation of the different sources that have been selected through the years and for this exercise. And I believe, most of these exercises the sources have come from the product of the expert meetings elaborating these tsunami sources. So in this last meeting in Martinique, the group felt that we should move into non-seismic sources, looking more now into details of landslides and underwater volcanic eruptions and subaerial landslides and also volcanic eruptions. So this is one of the things that we're moving now into. So we have prepared a list of seismic sources. So the group thinks that there should be a list of possible sources from this type of non-seismic sources. So that's everything I've got to show. With that, I just turn it to Rocky.
Well, thank you. It's a pleasure to be here. Yes, my 45th time, but I have to tell you, 29 of them were for hurricanes, training, emergency management, response. I represent the NOAA Science and Technology Advisory Panel. NOAA stands for the National Oceanographic and Atmospheric Administration, but it also has an alternative name that I'll explain in a moment, the National Organization for the Advancement of Acronyms. The TSTAP, which is one of our acronyms, the Tsunami Science and Technology Advisory Panel, was established by legislation by Congress that was enacted in 2017, and NOAA stood up the TSTAP in 2020, and I had the pleasure of being among the first appointees, along with Dr. Melgar, to the TSTAP. And we were charged with doing a review and investigation on the current status of the U.S. National Tsunami Program. We covered the entire United States from as far east as the U.S. Virgin Islands, Puerto Rico, the continental United States, Alaska, Hawaii, American Samoa, Guam, and the Commonwealth of Northern Marianas Islands. So we have a very wide scope of responsibility that we looked at. We began with the National Academy of Sciences report that was published in 2011. They did a serious investigation into the U.S. Tsunami Program, and then we updated it and spent a lot of time going through and writing 8 major recommendations with 22 sub-recommendations. If you scan that QR code, it will bring you right to our report. Some of our recommendations are being acted on right now by the National Weather Service within NOAA. And you may ask, why is it Weather Service and NOAA? And it's because, and many people don't know, that the National Weather Service, under its Organic Act that established it, has the warning responsibility for all of NOAA. So that's why tsunami warnings, advisories, watches, and bulletins are issued by the National Weather Service because it has a warning responsibility component of its enacting legislation. So most of our recommendations really focus on the quality of the alerts that people get. And as Christa mentioned, and is so vitally important, and it comes from my emergency management background as well, people aren't really interested in the science and the seismology and tsunamigenesis and so forth. They just want to know, is it going to happen? Is it going to happen here? Is it going to happen to me? And if so, what am I going to do about it? How will I be alerted? Where do I go? What do I do to be safe? Those are the fundamental principles of alerting and public safety. So we made recommendations that are focusing on improving the harmonization of the National Weather Service's 2 tsunami warning centers. We have one in Honolulu that is the Pacific Tsunami Warning Center, and one in Palmer, Alaska, the National Tsunami Warning Center. They work in conjunction in providing service for providing tsunami alerting for the entire United States. So we recommended that NOAA align and harmonize the tsunami warning centers so that they can act for each other. Currently, right now, when a tsunamigenic earthquake happens or a non-tsunami source such as the Hungatonga volcanic eruption that can cause a tsunami occurs, they independently solve the tsunami problem and issue an alert based on their independent analysis. So one of our recommendations is, and that NOAA will enact, a common analytical system so they're each solving the problem the same way. So it'll be a lot more consistent. They will undertake a comprehensive enterprise-wide technology upgrade for the entire tsunami warning system. The technology that goes into all the alerting is very complex, and some of it is built on legacy architecture, and so they're doing a major revamping of all of these systems to make it more up-to-date, up-to-speed, and both tsunami warning centers will be able to actively be redundant to each other so they can back each other up, which is a requirement in the legislation that established both of them. We also wish to continue the strong relationship that NOAA and the National Weather Service has with the U.S. Geological Survey, because that relationship is so important to make sure that we get the information correct and that we provide it to all the channels that are out there for people to receive and then act on. We also recommended that tsunami detection and observation systems be improved, and that's an ongoing process. There are lots of different ways to detect. Currently, our primary detection system are the DART buoys, the Deep Ocean Assessment of Tsunamis sensing buoys. They have bottom ocean sensors that relay through satellite signals to the tsunami warning centers when a tsunami is detected in the ocean column. DART will continue to be supported. It's a robust, well-known, well-understood technology that its data is incorporated rapidly within both of our tsunami warning centers. But there are many other ways of doing detection, such as sea level gauges, global navigation satellite system data, and in the future, smart cable technology detectors, strong motion detectors, and other technology that can further refine the detection capabilities of both of our tsunami warning centers. We want to provide more extensive and consistent and accurate tsunami messages and products. A product is an alert. That's just typical weather service speak. And our next acronym, they're going to be creating ATOMS. And I'm not talking about small particles. ATOMS means the Advanced Weather Information Processing System, AWIPS, Tsunami Operations Messaging System, AWIPS, Tsunami Operations Messaging System, ATOMS. Okay, so we've learned a lot of acronyms. But what that will really mean for the rest of us who aren't into processing all the different terminology is that the messages will be more robust, more consistent, and more accurate coming from both our tsunami warning centers and will appear on tsunami.gov, which is our consolidated website that provides all warning products from both tsunami warning centers in real time. So we're looking forward to having all of this information available consistently, cleanly, more accurately, and consistently unified among both warning centers. Further, we'll be developing enhancements to the Tsunami Warning Center forecast and alert systems. I mentioned the alerts, but the forecasting is really what our states and territories use to anticipate when tsunami waves may be arriving and where and the wave heights, to give appropriate and accurate warning to the public and emergency managers and other responders so they know what to do. There were total of 8 recommendations in our report. There are 4 more to follow, and the Weather Service and NOAA overall, along with our colleagues in the USGS, will be working on these over time. But I'm very pleased that our report has had a major impact. We just got NOAA's response to it just last night. So we're going to be going through that more specifically, but we really do anticipate very positive forward-moving activities by NOAA and its National Weather Service and our colleagues in the USGS to improve overall our nationwide capabilities for tsunami warning, unification, accuracy, and public safety. Thank you.
Well, thank you, Rocky and Alberto and Christa. So if anyone from the audience has a burning question for the panel, please walk up to the mics. Hopefully, this gave you an understanding of what it's like to be a tsunami specialist, uncertain science, unknown sources, competition from other natural hazards for resources, and trying to maneuver the federal government to act in an efficient way. My parents are psychologists, they'd call that a Freudian slip. It's hard, okay? It's tough to be in the tsunami business. So please, if you have any questions, walk up to the mics. I see somebody, is that you, Liz?
Yes.
Yeah.
All right. I'm going to ask a quick question. I know that we have developed new global key performance indicators, not only for the US, but on a global scale, that are going to be put out, I think, in the next year or so via UNESCO and the IOC. Now, how do you see your indicators, such as what you have in the advisory panel and what you're looking at as far as education outreach for things like Caribe Wave, fitting into those key performance indicators that are going to be applicable to every country?
Christa or Rocky?
Well, just to confirm, the Tsunami Science and Technology Advisory Panel is limited in its focus to the United States, but we do work very collaboratively with Christa and her team, and for example, she showed the Tsunami Ready indicators. That is a demonstrated collaboration among and what you might term as key collaboration or key indicators of performance. So again, it's through collaboration that we're doing that, but the TSTAP again is limited to the US only.
Christa?
Yeah, so one of the efforts has been, so right now, the tsunami warning system, right, is organized under UNESCO IOC. So it's under UNESCO IOC, it's a member state driven process. And as part of this, we have, and on the other hand, there's several other initiatives that are being established to try to make people more resilient to other hazards and things. So so we have the UNESCO IOC tsunami efforts. That's these coordination systems of which the United States is also a process. And then we have, right now we have the Decade of Ocean Science for Sustainable Development, which is another opportunity to try to advance our tsunami system. And then we have, there's a new initiative by United Nations, which early warnings for all. And then we have in the UN for disaster risk reduction. So we're looking at how to reduce this. So one of the efforts that we're trying to do is we're trying to align ourselves the most possible with these different efforts. So whether, for the countries, so within the tsunami warning system, for example, we're focused on the 4 areas that we act. So we have 4 areas of interest that we we're focusing on, so we're realigning our work and our project towards what it is, the identification of the risk identification, and then the forecasting, the detection and the forecasting, and then the warning, which is a national responsibility, and then the response, the other area that we all are working on is tsunami response and, well, it's called tsunami response, and then also resilience. So we're working on those areas together, and I think that, so we have these indicators, so we're trying right now to bring all these indicators, all these different programs together to make it easier for all the member states to be able to execute and try to create also alignments with the other hazards. So it's work in progress right now, but there's this effort to work together in these different components to try to advance, not only tsunamis, but the preparedness for other and resilience for other hazards as well.
Well, it's tough because every country is different, right? Every tectonic region is different. So while someone else thinks of another question that they might want to ask, I wanted to throw one at Alberto. So since you talked about science and you've been in these rooms where you discuss what's the worst likely earthquake, what do we actually know, what do we not know about a region, about the physics of ruptures, about hydrodynamic propagation and all of that, what do you see as the knowledge gap in understanding and planning for these kinds of events? Or if I put it another way, if money and resources were a non-issue, in that ideal world, where would you focus your efforts? And I'm thinking specifically about science and technology and research.
Yeah, good question, Diego. One of the things that the group would like to see is to start doing some probabilistic tsunami hazard assessment, because it all boils down to the different members, and if a member doesn't know or doesn't have that expertise, then it's not done. There are other limitations as well, but it would be nice to have that put into the mix of all the tsunami sources. One of the things that has been a problem for I think forever, and probably Christa can say something about this as well, is that the bathymetry. The issue of the bathymetry, the high resolution bathymetry for different tsunami simulations has been, since I got into the working group too, it's always been the issue that we would like to have some very good estimations of the inundation in the particular areas. We'd say that member nations, that they don't have the resources, but in a way have somebody to come over and make some bathymetry analysis, but it's kind of difficult because then there's the issue about who owns the data, and these are my resources, and you know that my resources are there, and it becomes a political issue at that point. Sometimes the nation has the bathymetry that we could use, but then they don't want to share it. So we have had these different issues through the creation, and we have tried to go around it. We have done some surveys with different members of the Caribe EWS, and at some point we wanted to say, well, let's just go in there and we teach how to do the tsunami simulations, and if you have your data, then just use it, but then you can generate something. And that has been one of the most difficult things in that particular working group. For ruptures and things that are more complicated, then you can imagine if this is simple, just make a simulation that's simple. But going to things that are more difficult and more complex, then I can imagine. So it's just a matter of who sits there. So if you get as a member, invited expert member in this group, then what can you put it on the table for making this advancement?
Thank you for that. I appreciate that. What you're describing is true co-creation of knowledge, right? Not just handing down the information to someone, but bringing them along in the journey to learn to be self-sufficient themselves, but also contribute to the broader regional good, which I imagine in the Caribbean, Christa, maybe it's particularly challenging given how many nation states and interests there are in the Caribbean compared to maybe, you know, Japan. It's just Japan. So when they do their calculation, it's easier for them in some sense.
Yeah, so in the Caribbean, when we talk about the Caribbean tsunami warning system, we're talking about 48 member states and territories. So not only do we have autonomous, you know, countries, but then we have the territories of the countries, which then have their own governance mechanism itself. So when our goal is making, you know, the Caribbean tsunami ready, you know, meeting all these indicators on you know, on understanding what the hazard is, and you know, and then getting all our response mechanisms in place to respond. We're talking about, you know, from some of the tiniest countries in the world, smallest countries, St. Kitts and Nevis, to huge countries, United States, Mexico, Brazil is even part of our system. So it's challenging, you know. So what we've been doing is we've been working so when we have this goal of making all of them tsunami ready, and it shouldn't be, you know, it shouldn't be dependent on what your resources are. Everybody should know, you know, what areas are at risk. So we've just been going slowly by slowly. So that's one of the good things about the Tsunami Ready program. That's a vetted program, you know, by United Nations now and by UNESCO. And so we've had funding coming in, and we're seeing, you know, more and more countries understanding first their hazards, so doing their tsunami inundation mapping. And some, you know, they get over, you know, they're able to, they have their bathymetry and they provide that, and working with experts, then we do those inundation maps, and then we go into, you know, the preparedness. Some countries, they don't have that modeling expertise, they don't have the data, and so then we have to, you know, we have to use other types of models to get to what that hazard is. But the idea is that, you know, everybody, it doesn't matter if you're the tiniest country in the Caribbean or you're one of the largest countries in the Caribbean, everybody should be ready for that next tsunami. And you know, where those, I have identified those areas at risk, have practiced with their population, have an informed population, and protocols in place for them to respond.
Thank you. I do want to come back to the bathymetry here in a second, but because it's a subject near and dear to my heart, having tried to model tsunamis. But there's a question from the audience, please.
Yeah. I'm Peter Heusler with the USGS. Just I'm curious of the panel's comments on the submarine landslide generated tsunami hazard, and the U.S. tsunami warning system is very focused on earthquake-generated, far-traveled tsunamis, which obviously can be big killers, but for example, in the *64 earthquake in Alaska, the submarine landslide-generated tsunamis were the biggest killer. So anyway, just curious the panel's comments on a larger scale.
Do you want to maybe, Alberto?
Yeah, definitely, thanks. Well, this is something that we're just starting to get into. If you're familiar with Caribbean wave exercises, and back in 2018, we did the Kikemjeni submarine volcano, which is 8 kilometers north of Grenada on the Lesser Antilles. And this year, we used Martinique. So we're slowly going into a different type of source that is not a fault rupture from a subduction zone or another fault that, you know, normal movement that can generate also that vertical motion. But it has been a challenge, because we tell PTWC we want to do this source, and so how we model it, and this has gone into the ICG Caribbean EWS meetings and sessions where we say, well, we want to do this type of scenario, but there's something that is missing. The mechanism just to generate that is missing, and we're trying to update everything with this group. But that then goes back. For example, the particular type of the landslide, we know, for example, in Puerto Rico, it useful for us, and I do some tsunami simulations from landslides because we have a very nice bathymetry that was obtained through the USGS during the first decades of the 2000s. So we have that bathymetry, and we know how to do the simulations, and we do it. But if you go a little bit to the east, where St. Kitts and Nevis, or you go to Grenada, the bathymetry there is missing, or they have it and they have it locked down. So, but they don't do the simulation. Some territories from France, Martinique, Guadeloupe, they have Saint Bart's. They have done very nice bathymetry surveys of all the area of the northern part of the Lesser Antilles, and they have done simulations there, but they are able to look at that landslides that are easily identifiable on the bathymetry. But the rest, what happened on the Aves Ridge? So is there bathymetry we can take a look, landslides that are smaller or bigger, and if an earthquake occurs that it's big enough just to trigger a tsunami, a landslide. So this is a long way to go for this particular group, and I know it's as I said before, it's pro bono. So well, at least for me, I had to do all of this on top of the other things and responsibilities of being a professor. So
Yeah, I don't think it's just your group, Alberto. I think landslides are terrifying if you know about tsunamis. Is that you, Amy?
Yeah.
Please.
Okay, a bit of a follow-up question on the sort of non-seismic source is, how would this shape our observational networks if we're moving more into landslide-generated or volcanically generated tsunamis? Are we going to start putting darts near volcanoes or tide cages in places that are further away? Is there a plan to incorporate some of this into decision-making?
That's a wonderful question.
Yeah, well, one of the exciting activities or actions we have as part of the Ocean Decade for Sustainable Development, which is 2021-2030, is really looking at new ways and integrating new ways of detection of tsunamis. So basically right now what we do is we use earthquakes as a proxy, right? So we have an earthquake, and then, based on that earthquake, then we model the tsunami that can happen. And then we use tide gauges or darts then to confirm, if a tsunami has been generated, and to tweak our forecasts on what the impact may be. But these stations, especially, if we're talking about submarine landslides, we're talking about volcano eruptions. I mean, this earthquake, using the earthquake as our trigger for putting out messages is not going to work. So we need something else. So one of the exciting things that's been worked on for decades, but finally is getting a lot of traction, is SMART, which is taking advantage of the submarine communication cables that are just lying across, in the Caribbean. I mean, they're all, there's a lot of them in many places where we don't have observations. So instead of using earthquakes as a proxy, hopefully we're moving towards the detection of the tsunami. So you're able to detect initially the tsunami, and from there make the modeling, not have to use your earthquake as a proxy. And I think that is, using that type, if we're able to really take advantage of these telecommunication cables and integrate them into our system, and then complementing, of course, with our coastal sea levels, and we have our darts, and we have our seismic stations, we'll have a much more robust system. So I think that will really help address the issue that we have, like of these, what we call let's just say, you used to call them atypical tsunamis, but they've become like the typical ones, because we're having, every tsunami seems to be a little bit, look at Tonga Tonga, right? That we will have this system that's more robust for all detection and alerting for all tsunamis.
That will require training too, right? Because in the warning systems, we're so focused on the seismology driving that first alert.
Yeah.
I think there's a question there.
So, Pat Joseph from the Seismic Research Center. Not so much a question, but a comment. So, one of the past Carib wave exercises, in St. Vincent, they used the opportunity to test an evacuation by sea. And this happens because in the north of the island, it can become isolated depending on the type of event. And this actually led to quite a bit of information that helped when the eruption did happen in 2021, because they saw the challenges of having to do that evacuation by sea. So just in terms of the utility of the Carib Wave exercises on informing that process, it was quite valuable. So.
Yeah, so Carib Wave exercise, I mean, you know, we're working with, you know, a low frequency event. So, you know, people can just forget about it. I mean, we're focusing on hurricanes. You know, we have, you know, for every tsunami, we have 100 hurricanes coming through, you know, so more than that. So with the Carib Wave, we've been, you know, every year in March, we have this exercise, and then we develop scenarios for these exercises, and then countries then, you know, go out and they test their protocols and their systems, and they get the communities involved. And so if it weren't for these, you know, probably for these annual exercises in addition to the World Tsunami Awareness Day, many people would not have, you know, thought of these important other initiatives that need to be taken to save people's lives from these type of events. And so that's when they're practiced. So every March, you know, it's on everybody's calendar, and they exercise, and you get exposed to these different types of scenarios, like, you know, we just had the Mount Pelée scenario. And I mean, it was like, okay, we have to rethink the way we're going to warn. PTWC do not have the data per se to be able to warn for tsunami generated from a volcano eruption, because it doesn't, the earthquakes are much too small to trigger action, right? So in that way, we developed, in fact, even a protocol whereby the volcano, we're starting to have memorandums of understanding between volcano observatories and the PTWS within the Caribe EWS framework, whereby they will basically act as the seismometer, right? Instead of the seismic, you know, they will tell and inform PTWC that there's an event that could be a threat, and so therefore, and if that happens, then they start issuing the corresponding products.
Sir?
Bruce Jaffe, U.S. Geological Survey. So education is key in tsunamis. Education saves lives. One thing that would improve the education credibility is validation of models for tsunami generation, propagation, inundation, so that the public can trust the information coming from the scientists. So what's being done in the Caribbean to validate the models?
Rocky or Alberto?
Through the National Tsunami Hazard Mitigation Program and its Mapping and Modeling Subcommittee. And I know, Bruce, you participated in several MMS workshops and meetings in talking about the tsunami model outputs and their validation. The validation is being done on an ongoing basis by the members, territories and states, to, as you said, to determine the accuracy of the information that the models are producing that lead toward better and more accurate public outreach and education. I know that's an ongoing activity that all of our NTNGMP partners are doing, both here in the Caribbean and across the United States.
And I think, Bruce, there's also a Powell Center effort right now that might be trying to tackle some of those issues. You look like you want to ask a follow-up.
No, I don't.
We have a couple of minutes left, so perhaps it's fitting that our outgoing president, Peggy Helwig, wants to maybe ask the last question.
So I guess I don't have to introduce myself. My question is, what can we as a society or a community or members of a community do to help and support this process?
Great open-ended question.
And thank you very much for the information.
I mean, there's members of our seismological community that are actively contributing in different facets of this, of the system. I think the identification of the sources is key. I mean, you know, identification of sources, and then, so once we have those, I mean, also then the monitoring aspects, you know, looking at new ways, especially these, what we we no longer want to call them atypical, because as I said, the atypical is becoming the typical tsunami. So from the non-seismic sources, but using some of our technology to drive that. So I think that is key. This ingest of this whole new wealth of data that could be coming from these systems like SMART and something like that is very important, and continuing to support the education and outreach. I think it's key. I always said this is a 50-50% proposition. 50% is the science, and then 50% is the people that are ready to respond, and their response is informed by good science, and that's what SSA has always been so good at. Promoting that and promoting these dialogues in spaces like this are extremely important.
Yeah. Rocky?
The silos is important as well. Collaboration and sharing your knowledge together as a community really helps us improve. Just even having this panel here at SSA is an incredibly important way that we can demonstrate that collaboration and our ongoing learning and application of what we've learned to it. So thank you for having us.
Yeah. Alberto? You got the last 29 seconds.
Well, we at this group, working groups, we're open to, they consist of members from the different member nations. But we also have some other invited experts. And as you can see on these different working groups, for example, working group 1, which deals with the instrumentation. And the last one is we have been incorporated the GNSS one. So, and the tide gauge also. So the working group 1 is a subdivision of the seismic, the geodetic, and the tide gauges. And they are composed of different members from, for example, from this community in there, and we encourage them to just reach out to us and say, well, I'd be interested in working on this particular thing. We would be more than happy to have you.
Thank you. Thank you all for attending tonight and hanging on till the end of the meeting. Tsunamis are low probability, high consequence events that require multidisciplinary research, action at all levels of government and society. So hopefully for the students among you, get excited, get involved in something like that. And we'll see you around tomorrow and Thursday. And please thank our panelists. Thank you guys. Yeah.